All right, welcome to The Explainer. Today we're going to do something a little different. We're not tackling some huge, sprawling topic. Instead, we're zooming way in on a single piece of paper. Just one document that completely, and I mean completely, rewrote the rulebook for our entire universe.
And here it is. I know. At first glance, it just looks like, well, a page from an old scientific journal, right? It's dense, it's in German, there are some equations. But this page, published on November 25th, 1915, laid out an idea so revolutionary, it totally flipped our understanding of gravity, space, and time on its head.
So that really brings us to the core question, doesn't it? What is it about this particular collection of symbols and words that makes it one of the most important artifacts in the entire history of science? Let's dig in and find out. Okay, so we're going to break this page down, piece by piece. Think of us as archaeologists, carefully examining some ancient, powerful relic. And like any good investigation, let's start with the basics. Who wrote it, and where was it published?
So if you look right up at the top there, you can see the publication. The Proceedings of the Royal Prussian Academy of Sciences, and just below the title, you see the author's name, A. Einstein. Now you gotta remember, in 1915, Einstein was already a big deal in physics for his theory of special relativity. But this was the work that was going to turn him from a famous scientist into an absolute legend.
All right, let's zoom in on the title. It's just a few words, but man, they pack a punch. They hold the key to what this whole paper is about.
There it is, in all its glory. The original German Die Feldgleichungen der Gravitation. Let's just put that on its own for a second. It might not look like much, but believe me, those 4 words are the announcement of a scientific revolution.
So what does that mean? In English, it's the Field Equations of Gravitation. Yeah, I know, it sounds super technical, but think about it like this. For more than 200 years, everybody just assumed Isaac Newton had figured out gravity, case closed. Einstein wasn't just offering a little update or a patch to Newton's laws. Oh no. He was proposing a brand new operating system for the entire universe, all built on this radical idea of curved spacetime.
So why? Why was this crazy new idea even necessary? What was wrong with the old way of thinking? Why did physics even need a new theory of gravity?
And that's a fantastic question, because brilliant theories like this don't just pop out of nowhere. They're almost always born from a specific, really annoying problem, a mystery that the old theories just can't solve.
And what's cool is that Einstein tells us exactly what that problem was, right there in his introduction. He mentions, and I'm paraphrasing the German here, his goal is to explain the perihelion motion of Mercury. And let me tell you, this was a huge unsolved mystery at the time.
Okay, so here's the deal. The planet Mercury's orbit had this tiny but very persistent, strange wobble. And Newton's laws of gravity, they just couldn't explain it, not even close. Scientists tried everything to figure it out. They even made up a whole new planet, thinking its gravity was the cause. But nothing worked. And then along comes Einstein with his new equations. He runs the numbers, and what happens? His theory predicts the wobble perfectly. It was this stunning moment that showed, hey, this isn't a mistake in our observations. It was a massive clue that gravity was something much, much weirder than anyone had ever thought.
So we know the theory worked. It made a perfect prediction. But how? How did it actually work? Well, to get a handle on that, we have to look at the very heart of this paper, the equations themselves. And hey, don't worry, don't click away. We're not going to do a bunch of math. We're going to read them like a language.
This right here, this is the engine of general relativity. The whole idea boiled down into just a few lines of mathematical syntax. This is the language Einstein invented to speak to the universe.
So, how in the world do we even start to understand this? The best way is to stop thinking of it as math and start thinking of it like a cosmic balance scale. On one side of the scale, you've got the geometry of space-time itself, all the instructions for how it bends and curves and warps. And on the other side of the scale, you have all the stuff in space-time, the matter and energy, stars, planets, you, me, light, everything. And this idea leads to probably the most beautiful and simple summary of the entire theory. From the physicist John Archibald Wheeler, he said, matter tells space-time how to curve, and space-time tells matter how to move. Just let that sink in for a second. That's it. That's gravity. It's not some spooky force pulling things across empty space. It's just stuff following the curves in the road of space-time that are made by other stuff. It's an absolutely incredible and elegant idea.
Okay, so Einstein solved the Mercury problem. gave us this gorgeous new theory. Great story, right? But why does it still matter? Why are we still obsessing over this one page over a century later?
Because almost 110 years later, these equations aren't just a historical curiosity. They are more critical to our daily lives and our grand understanding of the cosmos than ever before. Seriously.
I mean, just think about it for a second. The GPS in your phone, it only works because it's constantly correcting for the fact that time literally runs at a different speed for the satellites in orbit compared to us down here on Earth. That's a direct prediction from these equations. Without that correction, your GPS would be useless, off by miles every single day. And that's just the start. Our entire modern understanding of black holes, the mind-blowing detection of gravitational waves rippling across the universe, the very foundations of how we think about the cosmos, it all comes from the logic spelled out right here, on this one page.
So let's just go back and look at it one last time. It's not just an old, dusty document anymore, is it? Now you see it for what it is. It's a map. It's the origin story for so much of our modern world. I mean, the fact that solving a tiny little wobble in one planet's orbit led to describing the birth and fate of the entire universe, it's just staggering. And it all started right here.
And that really just leaves us with one final big question to chew on. This one page changed everything we thought we knew. So it really makes you wonder, doesn't it? What's the next great idea? What future, universe-shattering theory is out there right now just waiting for someone to write it all down, maybe on a single page?